Watch carefully. An automobile engine block faced severe cylinder scuffing and warping due to the owner's oversight in not adding antifreeze, even damaging the block's securing screws. Initially considering it scrap, the owner, hindered by the vehicle's age and lack of available parts, inquired about repairs. A friend's recommendation led them to a repair shop in Peshawar, Pakistan. The first task for the mechanic was to address the stripped threads of the block's securing screws. Using a tap to break through the surface at the screw locations, it seemed the mechanic was set to use the nearly lost art of build-up welding for the repair. Those with a bit of welding know how to understand the challenge of welding such cylindrical steel bodies. But for a veteran with 53 years of welding experience, this was no issue. After preparing the bolt holes, the mechanic moved the steel body outdoors for welding. Due to the uneven warping, he buried the lower half of the body in the ground, heating only the upper half during welding. In resource-scarce Pakistan, charcoal was chosen for heating. To reduce costs, the mechanic buried the body in the ground, piling ash and dirt inside the steel cylinder. He evenly distributed charcoal over the block surface, sprinkling diesel for easier ignition. Lighting the charcoal with a lighter, he aimed to heat the block's surface to precisely 799 degrees no more, no less, to prevent temperature differentials during welding that could cause cracking. Once the temperature hit 799 degrees, the mechanic immediately began build-up welding the screw holes using oxy-fuel welding with cast iron welding powder. At 69 years old, this welder's age belied his 53 years of experience. In his hands, nothing was unweldable. If others could weld it, so could he. If they couldn't, he still could. Midway through, when the steel body cooled below the effective welding temperature, he resumed heating with charcoal. Another mechanic used a fan to increase airflow, rapidly raising the surface temperature. After heating, the build-up welding continued. Once done, the block was left to cool naturally. After cooling, the mechanic removed the block from the pit and rinsed it with water. To check for cracks, he brought the block indoors and used a grinder to smooth out the welding scars, checking for cracks throughout the process. After grinding, the block was taken to a drilling machine for precise hole making. Even slight deviations could prevent the cylinder head and block from fitting together. Once drilling was complete, the mechanic addressed the uneven steel body surface. Securing the body to a surface grinder, he started the machine. During high-speed operation, sparks flew as the block's surface was ground down about 0.1 millimeters. After grinding, the block underwent boring. The shop's tools were comprehensive, offering boring, grinding, and shaft machining. Post-boring, as the cylinder's inner diameter had increased, a new steel sleeve was inserted. This raised a question: does anyone know which vehicle this engine belongs to? After inserting the sleeve, grinding resumed, this time controlled within 0.5 millimeters to avoid reducing the combustion chamber volume, increasing the compression ratio, and risking detonation or valve damage. After grinding, the block was bored to the correct size. Finally, the block required honing, the most crucial step in this engine repair, creating a uniform, symmetrical crosshatch pattern inside the cylinder. And here's another question: what's the purpose of the crosshatch? With that, the engine block was repaired, or rather, remanufactured. If you like, please like and follow.